All right, so here we have a seed. I've pre-drawn it because I know you know how to make these. They're not complicated at all, obviously, but it's going to be the base of what we're going to do here. What the objective of this is to try and create a square from 13 circles and then use that square to create a pentagon. Um, Typical seed, you've seen it a million times. I've got my horizontal horizon. I'm going to now rotate this horizon by 90 degrees and overlap against what I've already drawn. And the reason for that, once I draw this line, I'll tell you. The reason for that is we want to make a square, but we only have 2 points right now, or two spots, 4 points that we can use to create those lines. If we, apologies, struggling to walk and talk at the same time. If we rotate and have a second seed oriented 90 degree to the first, we will be able to duplicate these points over here, and that will allow us to build a proper square. So I'm just going to verify my compass is the right length. Okay, and then doing the same thing I did for the first one, I'm going to draw a second seed over the first. It will be 90 degrees to the first. And this will create a nice, beautiful little iris pattern. Something that you might have seen if you ever played with a spirograph when you were a kid. Something similar, anyway. All right, there we have it. There's 13 circles here. Take my pencil. I'll draw out the square without getting my head in the shot. I like to use the sorry, I'm getting hung up on perfectionism here. I like to use these points here to verify that I have an actual straight line with respect to the rest of the circle. It's just easier to make sure we're straight. Okay, so now we have a square. Now this square is built on the circle, but it is not squaring the circle. Something important to note here. In order for this square to square the circle, these intersect points need to be shifted by 2.4 degrees in order to be a properly squared circle, mathematically speaking, as close as you can, given that it's an irrational number. As it is right now, we're intersecting at the 30 and 60 degree point, and it needs to be, I believe this one, instead of 60 degrees, it needs to be 62.4 degrees. And that would shift this line that way a little bit and change would also shift up here, and everything would shift. And we would have a properly squared circle. As it is right now, it isn't squared, but it does tell us an important piece of information. And that's based on where the center of the quadrants are. I've picked one quadrant, And I'm finding the center of it because that will give us the length of the radius of a circle. And that circle is special with respect to this circle. Just going to trace out the circle using my compass. Realize you can't see it because my hands are in the way. I draw this circle. The special relationship we have here is we used this circle. We found 12 points along it with our 12 surrounding circles. We used those to build this square, which allowed us to mark off this point here and find the radius of our smaller circle, meaning that these two circles are now in phi proportion to one another. Okay, so this radius, call it R1. This radius is R1 times phi. All right. And in an effort to prove that, I'm going to take the radius of our original circle and I'm going to start plotting on the circumference of the new circle. So I'm just choosing the bottom here because it's a nice arbitrary place. I'm going to draw an arc across our, I can actually draw an arc across both because there is something neat to observe here. I'll do the same thing on the opposite side. Just trying to make it dark enough to guarantee that you can see it on the camera. Okay. Then on the first arc, I'm going to find the intersect between the new circle and this arc we've drawn. Do the same thing on the opposite side. We immediately notice a couple of things. Finish that line off. Okay. So on our smaller circle, we have 1, 2, 3, 4, 5 intersections that form a pentagon. Let's just get a look at it really quick. All right. And if we take a hard look at it, you can see that this pentagon was formed inside the small circle based on the radius of the larger circle. And that's because they are within phi relation to each other. So here's our radius of our smaller circle. And here's our radius of our larger circle. Drawing in green. I hope you can see it. See if I can make it up. Stand out a little bit more. Okay. Now from there, just to further demonstrate the relationship that's going on here, if we now take the total length of our first radius and our second radius, R1 plus R2 equals R3. Okay, there's R3. And we put that on our original circle and draw the same arcs. We notice two very cool things. Very cool things. Cool thing number one is that this is transferable. Okay, we're using R3 to draw arcs on our original circle, and we're also getting a pentagon, which means the phi relationship was preserved. R1 plus R2 equals R3. R1 is phi to R2, therefore R3 is phi to R2, which is remarkable. But the second remarkable thing, I don't know if you can see it. Okay, here's point one. If we look at where the R3 radius intersected with the second circle, you can see it actually intersected with the arcs from the first pentagon, which means that both methods found the same places on the outside circle, which again is, I don't have words to describe it. It's remarkable. So stay tuned for that. I'm running out of time with this video. Happy to touch base with it. Touch base on it, pardon me, again in the future. Just tracing this out, assuming I drew it half decently, you should see it's exactly the same as the first pentagon, just larger because it's on the larger circle and with larger arcs. All right. Yeah, I'm going to leave it there for now. Otherwise, I probably won't be able to post this video. But stay tuned. I'm going to follow up with the second method, which I don't think is as cool as this, but where I found it was cool. So, yeah, stay tuned, and I will try and post a second video with the second method.